Before we start any QGIS project, we want to make sure that everything is prepared in a structured way so that all of our input files are put in the correct folder and all of our session created files, what we've created inside the QGIS environment, is in a specific folder, and any reports are created in another folder. So what I like to do is prepare a template, which I would recommend, and you can have the folders here and an empty QGIS project file. To create a new QGIS file, open up QGIS, go to project, click on new. So you get an empty project, and then you can just go to project and click on save as. So you get a dialog, then you can navigate to your specific place and give it a name. So I'm just going to call this course new project. I'm going to click on save, and we should see that here. So once you've got the empty QGIS file and you've created through three empty folders, inputs, session, and reports, we can keep that as a template and then go ahead and just copy it. So I'm just going to go copy, paste it here, and let's give this project a name. So let's call it drone mapping exercise. And so inside this, I have these 4 files. And if I'm creating a new project, what I would do is just duplicate this template file again and then rename it as 2 dot whatever name I want to give it. So that way I can keep track of a sequential way in which I'm carrying out the projects, and it's a good way to keep everything organized and you have a project ID of sorts. So entering into that drone mapping exercise folder, I'm going to quickly rename this QGIS file as drone mapping exercise DME and hit enter. So now we start off with feeding our project with our input data, which in our case will be the drone mapped data. Now you can process this in a number of ways. We'll go over that in a separate video, but I have used WebODM. And in WebODM, we have a much cheaper cost compared to other softwares. And actually it's free if you can set it up on your laptop and your laptop is well spec'd. I'm currently running a Mac M1 Pro and it's decent for most tasks, but it is still loading on your CPU. And if you're doing a lot of drone mapping work, it might not be too practical, especially when you're touching the 1500 image mark, which is the limit for the free plan. What I've got is a business starter plan, and that's at about $22, and it totally comes up to about $420 per year, compared to the other softwares which range from $3,000 for Pix4D to about 4,200, and all of these are closed softwares. So yeah, WebODM, if you're using it, you end up with a zip file once you process it. Currently in this project, for an experiment for this exercise, I will be showing you this processed asset zip file, which would have all assets. And I've carried out the task for a regular orthophoto, which is a standard deliverable. And I've also added digital terrain model and digital surface model. So if we were to open up that zip file, this is how it looks. What I'm going to do is open up the inputs folder of my QGIS project and go to ODM orthophoto, take this, copy it, just paste it here. So that's the RGB map. Then I'm going to go and take the terrain model and the digital surface model, which is DTM and DSM for short. Then we're going to manually rename these 3 input files as per a particular nomenclature. What I've settled on is this nomenclature here, which is iteration, type, and altitude. Now, iteration is if you have multiple flights on the day, you might have different, let's say, flight mapping or mission planning considerations. If you just have one day, you might use the date itself as an iteration indicator. Basically, it is to indicate the uniqueness of a particular flight on a particular day. But if you have only one flight in a day, you could just go with that. So let's assume we just have one flight for now. And what we're going to do is rename it. So I'm going to remove the ODM part. Let me enter the date, 5 December, and then give it an underscore, go on the other side of orthophoto and mention the altitude, which was 400 feet. So in this way, we're already encoding some information for us to easily perceive at first glance as to what input file was used. Similarly, for the DSM and DTM, we're going to do the same thing. Let's just give it 5 December and DSM remains, and then we add the altitude. Similarly for the DTM. And here the reason I'm keeping 5 December as one word is so that my program, I'm running scripts later to make things easier, but this is the only sort of manual naming step which is involved. And so for those scripts, it's designed to understand details about the input based on where it is separated using the underscore. So the first word till the first underscore is considered as the iteration. So that's an indicator of what is defining its uniqueness. Is it the date or is it a particular type? For example, if I'm having multiple flights in the day, I might choose to have RTK on one and not have RTK in another, etc. All right. So now that we're done with that, we're going to move into the scripting part and tie all of this together. So the way I do things is I have an independent Python scripting workflow, which integrates with the same folder structure, and also within QGIS Python workflow, which also integrates. Now, the reason you might want to have two is to, first of all, do things which you can't do in QGIS with specialized packages like Rasterio, etc. It's easier to set up the environment separately because QGIS can be a bit picky with installing additional packages. So the QGIS scripts which we'll be using separately, the Python inside that, we're going to use the existing packages as much as possible, what's existing in the QGIS console. And for the separate Python workflow, which is using Rasterio and these other open source geospatial libraries, we'll be using a standalone dashboard for that. I've used Plotly Dash to create this dashboard, and this is how that works. So first we start by taking the path. So let's just copy the path name, and then I come into this, and on the top, I can just paste in the path name without the quotes, enter it, and then our project directory has been set. We don't need to do the first two steps, KML to GeoJSON and GeoJSON to KMZ. These are basically to translate the drone boundary files back and forth. So I could convert it to GeoJSON, play with it on QGIS, and import it back into the remote by converting the GeoJSON into the KMZ file. But that's in a separate video. So the first thing we're going to start with is the raster clipper, where we'll be clipping it to the boundaries. But before this, I will mention that this toolkit, as soon as we've initialized this project directory, it has already set up all of the required folders and subfolders in that particular project. We did use the template initially, but the template can be difficult to maintain. And if you're using this, you don't need to have the template. You just need to have a parent folder, and then inside that you have the QGIS project, and then you initialize that parent folder, and all of the other folders will be initialized automatically. So what we would have got is now, although this is copied from the template, there were some folders which were not in the template because that's out of date, but the script is maintained to be up to date. And so this is the single ground source of truth. And in the session, we can see boundary clipped. All of the clipped files will show up here. The DSMs in one folder, the DTMs, hillshades, orthos, and some JPEGs and all of these kind of things. The GeoJSONs, which are the shape files, any kind of boundary, any kind of annotation will show up here. The insights will show up here. We won't go into that right now, but that is another thing which happens when we paste in the path. So now you must be wondering, what are the boundaries we're going to clip to? So let's open up the QGIS file. After opening, let's make sure to drag and drop the inputs, which we just recently renamed, from that folder into the layer panel. As you can see, this image will have distorted boundaries on the edges. And of course, you might have captured more data than is necessary for your analysis. And we want to keep things neat, tidy, lean, and so we're going to do the boundary marking step next. For the boundary marking, there's a couple of different ways to do things. One is you could use a standalone GPS device, something like a Garmin GPS Mapper 66SR, or some other sort of a phone app perhaps. But yeah, of course, the GPS Mapper Garmin device gives you 6 feet of accuracy, which is better than a phone generally, especially in areas where you have a canopy. And if you do get these kind of files from the GPS Mapper especially, you would need to convert the GPX file to a GeoJSON file. And if you're using a phone app, you most likely have an option to export it as a GeoJSON file. But what we're going to do is make sure that we have a uniform GeoJSON file structure for making any kind of boundary markings. So now I quickly want to remind you that if you did use an external device to pick up the boundary of the land, of the area of interest, we would be dropping it directly into the GeoJSONs file here in the project directory. Otherwise, if you're going to use QGIS to mark it, and hence we have this hybrid sort of a workflow where we have the Python script on the one end, we have the QGIS interface to do other things, and this all comes together nicely in a seamless way. So if we were to use QGIS, we would come back here and we go to layer, go to create layer, select the new shapefile layer. Let's navigate to our project directory and go to session, go to GeoJSONs, and let's save it as area of interest boundary dot geojson and hit save. Okay, then we come to the geometry type, select polygon because we're going to be drawing a polygon, and that's it. Click OK, and now we have this shapefile which is shown up on the layer panel. With that selected, we go to this toggle editing button and then click on the add polygon feature, and let's add a polygon by clicking once, clicking again. Let's select a large area. Let's include that lake so that we have some distinguishable features to work with. So once you're done, we right click to close it. We were left clicking to drop the point. After we've drawn the whole boundary, we can right click it to finally close it up. We can leave the ID as null for now, just click OK. See, right now we can't see this because it is below the orthophoto. So let's make sure to bring this boundary as the topmost layer so that we can see it from the top. Let us go and click these pencil icons and save this, save the changes. We have to select that area. We have to select that layer first, click on the toggle editing button to remove the editing, and let's just quickly save it. So now when we look at the folder in the GeoJSONs, we have 5 new files which have shown up, and none of it is GeoJSON, interestingly enough. And so what we want to do is, after that initial shapefile layer has been made and you put some points, you need to make sure to put some points first. What we're going to do is we're going to export this. So we right click on the layer, we click on export, go to save features, select the format as GeoJSON, make sure we're in the right directory. It should be set now. So let's just rename that again, area of interest dot GeoJSON. Save it. We can leave everything else as it is unless you see some things you want to change, but the default options are fine. Let's go and click OK. And then we finally got the GeoJSON file. And this is how that looks. So we have 7 files now because when we created the GeoJSON, we created 2 more files, a QMD file and a GeoJSON. But what we're going to do is delete all files except the GeoJSON file, and we're going to use this for everything we need. Back over in QGIS, we see that as soon as we saved the features from the initial shapefile as a GeoJSON, we got a new layer up here on the layer panel. Let's go ahead and delete the previous one so that we don't get confused. We can just hover the mouse over that layer and we should be able to get the actual location as well. As we can see, that was the .geojson file. And so now we have our boundary. So once we have our boundary file, we can go back to our dashboard tool, which is in pure Python using plotly dash. We're going to quickly refresh this. Make sure our path has been set, come to the raster clipper, and now we should be able to see the boundaries automatically populate in this tool in the drop down. So there we have area of interest.geojson, select that. And for the input raster files, just let's select all of these inputs. Right now we have 3. We have the orthophoto, which is the RGB raster. Then we have the analytical layers, which are DSM, digital surface model, and the digital terrain model. You might also have a multispectral layer or other sorts of layers. And then I'm going to click run clipping, and it's going to take a moment and do all of this seamlessly in the background. Now, the reason why the GeoJSON you noticed was a little bit of a roundabout process to do in QGIS. And as you start using QGIS more and more, you will realize that it does have some of these quirks, but as long as you know what to do, you should be good to go. And I'm going to help you with that. So now we know how to make the GeoJSON file, and let's take it from there. Now we have our files which have automatically been renamed and stored in the relevant folder. And that's again another advantage of using scripting tools, because you don't have to go through that tedious process of selecting where to store it, etc., which you saw us do in the GeoJSON scenario. So now if we look at the folders, we should see the newly cut orthos, which are the input files, the raw data. Any guesses as to where we would see it? It did happen in the session. So we go to the session and we go to the boundary clipped. And here under the orthos folder, we should see which are the orthos. Okay, actually there was a typo in the naming of the initial input DSM file. I hadn't put the dot before the diff, so then it took it as a regular ortho and it put it in that folder. But now things are cleaned up, and so you should have only one ortho, which is the RGB. The DSM should find its place in the DSM folder and the DTMs here. And the reason we want to make folders for each of these is because you might have smaller boundaries inside this larger boundary. And so now when you have more and more boundaries, think about what's going to happen to the files. You're going to have more DSMs, more orthos, and if all of that was in one big folder, it's going to be hard to keep track of where your files are and what it's talking about. So in that scenario, all of the sub boundaries would show up in the relevant folder of their type, which is a DSM. It would show up here, like, sub boundary 1, for example. And that's also why folder structuring is important, and make sure to name your input files well. Everything else from here should be okay. Oh, another thing to note is look at the way it's named this file. It is remove the underscores in the boundary file. We had named it area underscore of underscore interest. It's removed all of that and it's converted it into camel case. So it becomes area of interest is one word separated by an underscore, and then we have the remaining name of the actual orthophoto. Now that we have the clipped boundaries, we can import just those clipped boundaries so that we can keep our workspace nice and tidy, focused on what matters. So we're going to go click on the boundary clipped orthos, drag it and drop it here, and let's do the same with the DSM and the DTM. So they're all here, and let's go ahead and delete the initial DSM and DTM at least, right? So we're going to remove those layers. Let's keep the original larger ortho for reference, just in case we missed out some detail, but we're going to uncheck that so that it doesn't have to render layers in the way in which we want. So generally you want to keep the most visible layer on top. So I'm going to put the orthophoto on top. Let's zoom in a bit. And of course, if we have the boundary on top of that, we can see the boundary more clearly as well.